Okay, Assalamualaikum and hello everyone. So we are going into a new chapter, that is chapter 2, atomic structure. So in this chapter you will have 1, 2, 3 subtopics, and for this week we will cover subtopic 2.1, which is Bohr's atomic model. So Bohr's atomic model, the learning objectives will be as follows. There will be some new theories, okay, and a lot of calculation. So it's important for you to understand the concept of this chapter. So Bohr's atomic model. Bohr's atomic model means this is Bohr's idea of the atom. How does the atom work and look like? Okay, so basically he was the first person to have an explanation for the emission spectrum of hydrogen, and he proposed a theory of atom which he described that electrons circling a central nucleus which contains positively charged protons. Okay, and he also proposed that these orbits, okay, that your electrons move about and move in, can only occur at specifically permitted levels. So we will look further later. What does it mean as specifically permitted levels? Okay, so it is only at a quantized energy, a specific energy, okay, depending on the energy level of your electron. Okay, so let's look at the postulates atau assumptions that Bohr has made. Okay, so these 4 assumptions are important for you to understand the later concepts. So the first postulate says electron, okay, Bohr cakap electron moves in a circular orbit, okay, ni circular orbit about the nucleus, maksudnya around the nucleus lah, ni nucleus kita. While moving around the nucleus, the electron does not radiate or absorb any energy. So outgoing electron, okay, while it is orbiting about the nucleus, it does not absorb nor release any energy. That's what Bohr says. Second postulate, Bohr says that the energy of an electron in a hydrogen atom is quantized. Okay, quantized maksudnya ada specific quantity of energy. Okay, so specific energy lah basically. That is, the electron has only a fixed set of allowed orbits called stationary states. Okay, the term orbits, okay, is equal to energy level, shell, or even quantum number. Okay, so note that. So on your bottom left here, we have our hydrogen atom. So here we have the nucleus, and your electron is orbiting, okay, at energy level 3 atau third shell atau the third orbit. Okay, so when your electron is orbiting at the third shell, okay, this electron has a specific energy. How do we know the energy? We will use this formula. Okay, so since it is at n equals to 3, that means that to find the energy of this electron at the third shell, we will put 3 here and 3 here. Okay, so cari tu and insert your Redbug constant. So your Redbug constant is 2.18 times 10 to the power of negative 18 joules. So that means that your energy here will be in the unit joules. Okay. So if you want to find the energy of an electron at the second shell, you will just use the same formula, but your n is equals to 2. Alright? Okay. Next, still the same postulate. The energy of an electron is quantized. It has a specific value. Okay, macam saya cakap tadi lah. The value, okay, the energy of your electron is specific. Okay. Contohnya, contoh. Kalau awak kira E1 ni, okay, negative 2.18 times 10 negative 18 joules over 1 square. Maksudnya awak punya value is negative 2.18 times 10 negative 18 lah kan? Sorry, ni 18 kan? So that means that it cannot be lebih atau kurang dari itu. Okay, kalau E2, okay, awak cari the value 18 joule over 2 square. Okay, awak cari that value. Your value of your energy of electron cannot be anywhere between these two values. Okay, maksudnya it can only be this or E3 or E4 or E5, okay, and so on. Tapi it cannot be any other value between E1, E2, E3. So maksudnya dekat sini, okay, let's say any value between there, itu bukanlah value dia, okay? Sebab Bohr kata energy of your electron is quantized. Dia ada specific value which is this. Okay? Alright. So answer these examples. Okay. Third postulate, Bohr says that at ordinary conditions, okay, biasa-biasa ni tengah chill, the electron is at the ground state. Okay, so your ground state is a state when your electron has the lowest energy or the lowest energy level. Okay, that is actually n equals to 1 lah. Right? So, if energy is supplied, if you give your electron energy, the electron will absorb the energy. Okay, dia ambil tenaga tu and is promoted from a lower energy level to a higher energy level. So, promoted macam naik ni lah, naik pangkat. Macam tu. So, dia akan naik dia punya energy level, okay, to a higher energy level. So, bila dia dah high, the electron is excited. Okay. So what happens next? Okay. If you look here, okay, yang postulate number 3 tu we can show the excitation with or the transition of your electron, okay, to a higher energy level with this blue arrow. Okay. So after your electron is excited, okay, dia dah high ni, dia dah banyak energy, your electron will be unstable, guys. Unstable. Okay. So, apa akan berlaku bila dia unstable? It will fall back to a lower energy level. So, dia akan turun balik. Okay. And bukannya dia turun je biasa-biasa je. Dia kena release a specific amount of energy in the form of light, okay, radiation called photon. Okay, so there will be photon emission. Dia keluarkan photon. Okay, so the energy of the photon equals to the energy difference between the levels delta E. Okay, this is the formula to find the energy released, okay, when your electron falls back to a lower energy level. So, cerita kita tadi, awak punya electron is excited from a low energy level, which is n equals to 1 atau energy level 1, to a higher energy level, which is energy level 3. Okay. So a specific amount of energy is absorbed. Okay, bila naik atas ni, a specific amount of energy is absorbed by our electron. So you can use this formula delta H, okay, where E1 is your initial minus E3. Patutnya ni salah ni. Ni E final. So E final awak and E3, okay, ni E1, okay, betul kan? And then once your electron is excited, it will fall back to a low energy level. So in this case, okay, kalau ikut sini, dikata awak akan fall back to the energy level 1, okay. So to draw how to show the transition, okay, you will draw your arrow that your electron falls back to the ground state, okay, atau any other energy level lah. So in this case saya letak ground state. So when that happens, awak akan ada photon emission. Ni photon emission, okay. So for this one, okay, delta E ni, ini adalah EF minus E initial. So your E final for electron falling back should be 1, E1 minus E3. So please fix that, alright? Okay. So, daripada cerita kita tadi, okay, we can translate whatever that happened here, okay, into an energy level diagram. Ini bukan energy level diagram. Kalau energy level diagram, maksudnya dia ada level lah. Okay. So, since we know that energy level is your N, right? So, for hydrogen atom, you can draw the energy level where your y-axis is the potential energy, okay, your energy, and your x-axis or x-axis are your energy levels. So when drawing the axis, okay, your energy levels, okay, the gap should become smaller as it increases the energy level, okay. So you can have n equals to 5, n equals to 6, n equals to 7, n equals to 8, and finally you will have n equals to infinity. Okay. So if you look closely at n equals to infinity, okay, your line here ni is actually the convergent limit. Okay, you can see that dia tebal, this line, to show that the line is so close together, okay, bila n equals to infinity. So just now our electron absorb energy. So this one, this blue arrow shows that your electron has transition from energy level 1 to energy level 3, and it became excited here, so excited, okay, and then it will fall back to energy level 1. So here your energy is released, so there is photon emission, okay, ada laser keluar, ada light, okay. So the amount of energy emitted when the electron falls can be determined by this formula, okay, where delta E is equals to EF minus E initial. So this is the final energy and this is the initial state energy of your electron, okay. So derive, and you will use this formula in order to find the amount of energy emitted when your electron falls. Okay, maksudnya bila ada energy release, okay, photon emission, you can use this formula to find the energy of your photon. Okay, so ingat RH ni adalah 2.18 times 10 negative 18 joules. It is good for you to remember this so that when during exam you don't have to look back dekat constants punya list tu lah. Okay. So kurangkan kecuaian. And remember your answer will be in joule. Okay. Because RH is in joule. Okay. So Ni will be the energy level at initial state. Maksudnya awal. Okay. And F will be the energy level at final state. Maksudnya after that. Right? Okay. The photon, okay, atau the amount of energy released by the electron transitions between two energy levels has an appropriate frequency, mu, and wavelength, lambda. Okay. So these are the symbols for frequency and wavelength respectively. Okay. So sometimes you are given, let's say, mu atau wavelength to find your delta E, the energy released. Okay. So when this happens, okay, you can just masukkan your Planck constant H ni. So this is 6.63 times 10 negative 34 joule second. Okay. And your frequency mu. So frequency, selalunya your frequency will be, you have to make sure it is in per second. Okay. So nanti awak punya delta E will be in joule lah. Okay. Because H is in joule second times mu, which is per second. So seconds tu akan cancel out and you will get your delta E in joule. Okay. So let's say if you are not given the frequency, okay, tak ada unit per second tu, dia bagi awak wavelength, okay, lambda. So your lambda will be in nanometer. Okay. If it is in nanometer, you have to make sure that it is in meter. Okay. So since nano is 10 negative 9, so make sure to put in that value, okay, to get in meter lah. Okay. So if you are given lambda instead of mu, you will just use this formula and rearrange it to find delta E. Okay. So basically what happens is that we rearrange to find mu equals to C over lambda. And then C over lambda ni masuklah sini. Okay. And then you get this formula. Second formula. Delta E equals to HC over lambda. So H is your Planck constant in joule second times dengan awak punya speed of light. Speed of light is in meter per second. And your lambda will be in meter. Okay. So nanti meter akan cancel dengan meter and second akan cancel dengan second and your answer will be in joule. Okay. So make sure all your values are in the correct unit to get your correct answer. Alright. So let's say for this example, 1 mole of electron electron drops, maksudnya dia fall from the 4th energy level and equals to 4 to the 3rd energy level and equals to 3. So calculate the energy of the photon emitted and the frequency of this photon. So sekarang ni kita tengok kita punya value of electron is 1 mole of electron. So 1 mole of electron, you know that will be 6.02 times 10 to the power of 23 lah electrons you have there. Electrons. Okay. Okay. So first you need to know which is the initial and which is the final. So since it says it drops from 4th energy level, okay, mestilah dia akan fall daripada higher energy level to a lower energy level. So this will be your initial, okay, and this will be your final. So next, okay, we want to find the energy of photon emitted. That means you want to find delta E. So what formula will we use? We will use the formula delta E equals to Redbug constant bracket 1 over Ni square tolak 1 over Nf square. Alright? So since we know that our initial will be energy level 4, okay, so 4, so kita just masukkan the values. 2.18 times 10 negative 18 joules 1 over 4 square, don't forget your square, minus 1 over 3 square. Okay, and your answer will be negative 1.06 times 10 to the power of negative 19 joules. Alright? Okay, second question, they ask you to find the frequency of this photon. Frequency yang mana satu guys? Frequency will be mu. Okay, so since we know this formula, delta E equals to H mu, and we already have our delta E. So to find frequency, we just rearrange this formula. Okay. And then masukkan je lah your value. So you have delta E. Okay. In this case here, our frequency cannot be negative. So tak payahlah letak negatif ni dekat dalam this value. You will only take the value 1.06 times 10 negative 19 joule over your H will be Planck constant 6.63 times 10 negative 34 joule second. So for this one, you will get your answer 1.60 times 10 to the power 14 per second. Okay, so ingat frequency mu, okay, dia tak boleh negatif. Alright, so ingat when you are inserting the value of delta E, you are not going to put any negative sign. Okay, alright, so next we have a Redbug equation. So Redbug equation is the next formula that we can use. Okay, when wavelength emitted by the electron between two energy levels can be calculated using Redbug equation. So maksudnya bila kita ada wavelength, okay, lambda. So when we have lambda, we will use this formula to find the we will use this formula to find the wavelength emitted by electron between two energy levels, okay, using this Redbug equation. So basically bila kita diberikan n, your initial dengan final, okay, n1 n2, where n1 is smaller than n2, okay, ini bukan sama dengan initial final lah, ni n1 must be smaller than n2. So that means that you have to determine which is which. Okay, to find, we can use this formula to find the wavelength. Okay, so ingat, okay, bila awak buat this calculation, you will have to terbalikkan. Okay, terbalikkan your answer. Okay, terbalikkan this answer to get lambda, your wavelength. Okay, if you leave it like this is equal to 1 over wavelength. Okay, bukannya awak punya wavelength. Okay, so kena terbalikkan. So, let's do the example. So, calculate the wavelength in nanometers, okay, of the spectrum of hydrogen corresponding to n equals to 2 and n equals to 4 in the Redbug equation. So, kita tahu n equals to n1 must be smaller than n2. So, who is our n1? n1 will be the smaller one, which is 2, energy level 2. n2 will be 4. Okay, so to find wavelength, we just use this formula. When RH is, okay, tengok sini RH awak, okay, Redbug constant awak dia berbeza. Okay, yang ni kita guna yang dalam meter sebab kita nak cari wavelength. Okay, so take note. Okay, awak punya Redbug constant yang awak guna will depend on what you are looking for and which formula you're using. Okay, so sekarang ni kita nak cari wavelength. Wavelength must be in meter atau non-meter ke, whatever, meter. Yang penting dia adalah panjang. So, kita akan guna the Redbug constant with meter unit. Okay, per meter. So, 1 over lambda, your RH will be 1.097 times 10 to the power of 7 per meter. Okay, kita dah tahu kita punya N1 dengan N2. So, kita akan letak 1 over N1 square, which is 2 square, minus 1 over 4 square. Okay, so you will find that value, tekan calculator, dapat this value. Okay, and then ini adalah 1 over lambda. Okay, let's say this is x. So, to find lambda, you will terbalikkan lah. So, x negative 1. Okay, terbalikkan. Atau 1 over x. Okay, and your answer will be in meter. Okay, dalam meter. Oopsie. So, it will be x negative 1 meter. Okay, but look, the question asks for you to give wavelength in nanometers. That means you have to, let's say awak dapat 4.86 times 10 negative 7 meter. You must convert it into nanometer. How? You will take 4.86 ni, and then yang ni awak akan kali dengan 10 negative 7. Saya letak 17. Okay, benda sama. But then awak letak 10 negative 9 nanometers. So basically dia ini maths lah. 10 to the power of 9 kali dengan 10 negative 9, dia akan cancel out. But now you have your answer in nanometer, 486 nanometer. Okay. Okay, so do these exercises and we will continue with the next part.